In this video, we explore the relationship between the marginal concept and the concept of the derivative. Okay, and we will try to explore this concept using an example. Okay, so let's assume that you've been given a revenue function. So this is the revenue of the revenue at a sales level of Q items. Okay, and let's assume that this revenue function is minus 3Q squared plus 660Q minus 17050. Okay, so first let's deal with the marginal concept. Right? Recall in previous videos that we have defined the marginal revenue, okay, at a certain sales level. Okay, and let's say that that sales level is, say, 6. Okay, therefore, that would be the revenue for selling 7 items minus the revenue for selling 6 items. Okay, and one can compute the revenue for selling 7 items, okay, minus 17050, and then you subtract the revenue for selling 6 items, and this is just a straight plug into the calculator, okay, to get a number for the marginal revenue. Okay, the new idea in this section, okay, is that we will compute the marginal revenue for any value Q at any sales level. Okay, and that will allow us to find the marginal revenue at any value, not just the value of 6, but instead at any level. Okay, so the definition of marginal revenue is we need to find the revenue at a sales level that's one more than the sales level that we're looking at, Q. Okay, and we need to put in the revenue at Q plus 1 minus 17050, okay, and that is the revenue at Q plus 1 items. We then need to compute the revenue at Q and subtract it out, okay. So the revenue at Q is minus 3Q squared plus 660Q minus 17050. Okay, working out the algebra here, okay, let's go ahead and compute the algebra to figure out what the marginal revenue function is. So if you do the algebra, you'll get minus 3Q squared plus 2Q plus 1 plus 660Q plus 660 minus 17050. That was this line here. Okay, distributing the minus sign now will be plus 3Q squared minus 660Q plus 17050. Okay, we'll go ahead and distribute the minus 3, distribute it through this term to get minus 3Q squared minus 6Q minus 3. We'll add on the 660Q plus 660 minus 17050. And then we have the term in the other term minus the revenue at Q items was plus 3Q squared minus 660Q plus 17050. The 660s will cancel, the 3Q squareds will cancel, the 1750s will cancel, and all you have left is minus 6Q minus 3 plus 660, which leads to an answer of minus 6Q plus 657. This answer is our marginal revenue function. Marginal revenue function. Okay, and we can see that this is the marginal revenue function of the revenue function, which was given in the problem, minus 3q squared plus 660q minus 17050. Okay. Let's see how we can use this marginal revenue function, and if we bring in Excel at this point, okay, we will create a Q column, we'll create a revenue column, and then we'll create a marginal revenue column at a production level of Q. Okay. Now there are two ways to do the marginal revenue. Okay, we can lay out values 1, 2, 3, 4, 5, let's say. Okay, and then we can use the revenue formula, which would be equal to minus 3 times the quantity squared plus 660 times the quantity minus 17050. So there's the revenue. Okay. And the marginal revenue, you can compute it via the definition. The definition of the marginal revenue was right here. It's the revenue for one item, 1 plus the items, and then minus the revenue at the bottom. So look here, the revenue for 2 items minus the revenue for 1 item. That's the marginal revenue. Okay? And you can drag this down in Excel. So that's option number 1, to compute the revenue in that fashion. Or you can use the marginal revenue function at Q, right? And we can just do a formula for it. We now know that the marginal revenue function was minus 6 times the quantity plus 657. And notice that you get the same answers. Okay? So you have two different options to compute the marginal revenue function via the definition, the difference, or you can use the marginal revenue function. Okay? The question is, so that's the marginal revenue expanded on just a little bit. Let's add a new page, and we have for the revenue function of minus 3q squared plus 660q minus 17050, we have a function that's called the marginal revenue function. And we decided that it was, let me see, what did we decide that was? Minus 6q plus 657. Okay. We need to bring in a new idea. And the new idea is the concept of the derivative of the revenue function. Okay? And it will be denoted R with a little tick mark there called the prime symbol, R prime of Q, and it would be pronounced R prime at Q. Okay. What is R prime at Q? How do you find it? Okay. The steps to compute it, to find it, what you need to do is to expand our thinking beyond the marginal idea and expand on the revenue, right? What's the revenue if you're at a certain sales level? And then you add on a bit more, a wee bit more. So you imagine that your sales level has jumped just by a little bit. And this H, if H is equal to 1, that will get you back to the marginal revenue idea. But if H is not equal to 1, it's say a small number, right? That is where the value of R prime comes in. Okay? So let's explain what we mean by this. What you want to do is you want to show that R evaluated at a certain sales level plus a little bit more. What you're going to show is that that's equal to the revenue for selling Q items plus some number times h, which is h is the wee bit more that you sell. Okay, the number that you're going to get here, okay, the number that the number or the function that's in front of the h, this is going to be what's called r prime of q. So let me show you how this works. Okay, let's take our revenue function and put in q plus a little bit more, a little bump in sales. Okay, and that would be minus 3 times q plus h squared plus 660 times q plus h minus 17050. Okay. If you work out the algebra here, you'll get q plus h squared is q squared plus 2qh plus h squared. Distribute the 660 minus 17050. Distribute the minus 3q squared minus 6qh minus 3h squared plus 660q plus 660h minus 17050. Now notice that this term, and this term, the underlying terms, minus 3q squared, since you're adding, you can shift the order and add in any particular order. And what you have left here is terms that have h in them and then terms that have the h squared term. So, if you collect the terms that have only h in them, you will get minus 6q plus 660. And then there is the minus 3h squared. This term here is what we're going to call r prime at q, the derivative of the revenue function. This term here, okay, is the revenue function for selling q items. So the revenue for selling q items plus a little bit more is the revenue for selling q items, and then for the additional bump in sales, your revenue actually jumps by approximately minus 6q plus 660 times h, where h is how much your little wee bit, the sales, increase by. So what we've got here is r prime of q is minus 6q plus 660, which can be interpreted as the exact rate of change in the revenue at a sales level of Q for a small increase in sales of H. Okay. So what do I mean by this? Okay. Notice that if you're selling 6 items, okay, and you sell 6.01 items, where we can make some business sense of 0.01 items is some small, some tens, hundreds of one unit that's being sold. So if your unit of 1 is, say, 100, then 0.01 of 100 is 1 unit additional sold. So how much would your revenue jump, okay, if you sold just 1/100th of 100 units? So what you would do here is that you would do the average rate of change. It would be the revenue that you brought in for selling 6.01 items minus the revenue for 6. And then you will divide by how much your sales increased by, which is 6.01 minus 6. Okay. And this number right here for A7 needs to be D7 so that we can, okay. And notice that that answer is minus $6 for an increase of 0.01. Okay. if you look at your derivative function, derivative of the revenue function, which we now have an answer for, is minus 6q plus 660. So look at the derivative, okay, which is minus 6 times the quantity being sold plus 660. Okay, and drag this down. Notice that what you're getting is an answer for the derivative that is really close to the marginal revenue. Okay, so the derivative of the function and the marginal revenue are usually going to be numbers that are pretty close to each other. It's the derivative that is the more exact answer. Okay, so if we're looking at this problem, okay, in add page below, okay, what we're finding here is that the marginal revenue function is close to the derivative function. Both of them tell you about a rate of change in the revenue. Okay, it's the marginal rate of change is for an increase of 1, and the derivative is a rate of change for h being a small number. Okay, and it's r prime that is a more accurate reflection of the revenue change. Okay. The marginal revenue tells you what happens when you increase by 1 unit. R prime gives you how much your revenue is changing, even if you sell a small number. Okay, so that's what we're seeing in this video, and the relationship between the marginal revenue and the derivative. Okay, something interesting to note is that if we were to continue to look at this problem, the revenue function, note that the revenue function, the vertex of it, negative b over 2a, comes out to be 110, which says that if we plot the revenues, okay, out to 110, maybe even a little bit further, so there's passing 110, we'll go to 118. Okay, go back here and bring our revenues down. Okay, let's see, to about 100 and there we go, 18. There are all your revenues. Okay, and if you look at the marginal revenue, okay, we're getting there. Okay. Notice that around 110, where the vertex happens, the marginal revenue, okay, right here, that the marginal revenue, right, is getting close to 0. Okay, so the key idea here is that the marginal revenue close to 0 indicates a maximum or a minimum. Okay. If you go to looking at the derivative, right, let's look at the derivative, see which one is, let's check the accuracy here. Look at the derivative at these production levels. Notice that at 110, the derivative being 0 tells you exactly where the maximum is occurring. So if you look at the derivative equal to 0, this tells you exactly where the maximum or minimum is going to occur. So there's none of this guesswork in the marginal revenue about where the max min occurs. It's the derivative being equal to 0 that tells you exactly where this happens. Okay? So, in the next video we'll do a couple more examples of finding the derivative, since it seems so important on telling us where maximum and minimums can occur. Okay?